All right, so we are going to discuss chapter number 7, expert system, and this chapter we need to discuss regarding the recognition and understanding how expert system are used to produce possible solutions for different scenarios. So let's also check that what the syllabus wants to know from us. The syllabus says that we need to discuss that how expert systems are used to produce possible solutions for different scenarios. Then it says that they has components related to. We need to discuss the component that is related to the user interface, inference engine, knowledge base, as a database of facts and rule base, explanation system, knowledge base editor, and we need to discuss the scenarios that includes mineral prospecting, investment analysis, financial planning, insurance planning, car engine fault, machine diagnosis. Then we also need to discuss the concept of backward and forward chaining, and then we need to discuss the terms like data driven, goal driven, their uses in diagnosis, the gaming and artificial intelligence. So if I start this chapter, expert system. So expert system is more likely based on the decision making, but the decision making is not done by the humans. It's done by the machines. Expert system is like if you do not have a human and you need to replace it with the machine. So how you are going to work with it? Or if I say like, do you know anything about the database? So you could say that, sir, our database is basically a set of data which has rows and columns where you can work with the data, right? But it's like you spend your life developing your knowledge, like thinking and making decisions, and decisions becomes a fundamental part of your life. So what if I just include all of your experience, all of your decisions into some sort of database that is going to aid your decisions? Like for example, if you like the color red, so if I can enter it in a spreadsheet or database that if Mr. A likes color red, that means he's more interested into cars. If Mr. B likes the yellow color, that means he's more interested into motorbikes. So as you can see that these are, I'm creating some record, and based on that record, I'm creating some decisions. Like if he likes the color red, that means he is more likely into cars. And if he likes the color blue, that means that he's more likely into bikes or like this. So you see that your decisions are based upon your knowledge. And as you spend your life developing your knowledge, thinking and making decisions, so the decisions becomes a fundamental part of your life. Like they can be used to say like developing systems to aid the process. So if I make a computer system with the help of this database and with the help of this decision makings to take the decisions without the intervention of human, so this is going to be known as the expert system. That means to say that an expert system is a computerized system that attempts to reproduce the decision making process of an expert human being. That means that as a human we are making decisions based on our knowledge and experience, and if I want to replicate that into machines by giving the machines the ability to think and react and to make decisions, so this is going to be an expert system. An expert system is a computerized system that attempts to reproduce the decision-making process of an expert human being. That means that the person who designs, the person who develops an expert system is going to be known as an expert system engineer. So they are like designed to try and replicate the judgment of a human that has expert knowledge into a field. So by this, they can basically replace the human expert. Like for example, if I'm a teacher, if you try to replace me with a report, so you need to like add all of the knowledge that I have as a teacher of IT into that robot so that robot can teach you, right? So this is like an expert system. Expert system is like a machine where you give your informations and that can help you with your decision making. Now, after the basic definition of an expert system, we need to discuss about the several components of an expert system. Like how does this even works or what are the components? So some of the important components that are also a part of your syllabus right here as well, which I just showed you. So we need to take the information of them. So first of all, it says we have the user interface. Then we have the knowledge base. Then we have the inference engine. Then we have the knowledge base editor. Then we have the explanation system, and at last we have the method of output that is known as a screen. So now one by one, I'm going to explain you all of these components. So an expert system is the one that operates by prompting the user to enter certain data. So if you want to take a decision from an expert system, that means you need to enter the data by a prompt. A prompt means it's like generating the user or asking the user to enter this data. For example, please enter your name. For example, please enter your student age, like this. And when you give the command, when you give the prompt to the expert system, so the expert system is going to refer back to your knowledge base. Knowledge base is like where it has all the knowledge related to it. The expert system then is going to use the inference engine to help you in terms of your decision making. So expert systems are very versatile, and they can be used in a range of applications. So expert system can be used as a diagnostic tool as well, in financial planning, in risk analysis as well. Expert system can also be used for more fun purposes as well, like such as challenging chess opponents, or they are basically an example of an artificial intelligence, but they are more likely to stimulate the human decision making process. Artificial intelligence, the definition is simple. You can check it right here. Now, after that, I am going to discuss with you the components of an expert system. The components means, like, first of all, we have a user interface, the first component. So you would have known that user interface are most likely to be known as user UI UX. Like, let me give you an example like this, UI UX. So UI is basically the visual design that includes your colors, graphic design, layout, typography, and UX is basically the interactive design that includes the wireframing, information architecture, user research. It's like when you develop the design of your mobile applications, the layout. Like we have different social media applications, right? We have a Snapchat, Instagram, Facebook. You might have seen their user interface. You might have seen their user design, UX, user experience, like how the user is being experienced with the abilities or what's the design. Similarly, right here as well in the user interface part, the user interface is basically the way that a user interacts with the expert system. Like this could include a keyboard to enter a certain criteria, or like for example, if you are typing the command or something. Like maybe for example, if you went to the McDonald's, and in the McDonald's just you enter, you have the screen where you give the order. So you would see that the way you give the order is through by the touch screen. You select which burger you want, what is the flavor, if you want to top up anything. So your user interface is touch screen, right? So similarly in this example, in the user interface part of an expert system, which is the first component, so they are basically telling you that how you are interacting with the expert system. So the user interface will guide the user about what data they needs to input into the expert system, and they will then display any output from the expert system. So without the presence of a user interface, a user would need to know, like how these interactions will make it right. So after the user interface, uh, you can also take the example of this example as well. Like this is an example of a user interface. I mean, this screen. As you can see that this screen is basically asking you like, if you want to design with text prompts, how can I help you? This is like a way where you can enter the data. So this is an example of a user interface. So I hope this part is clear to you. I have a one question here as well. This question says that what could happen if the user interface design for the expert system is poor? So you could potentially reply to this question that if the user interface design is poor, so the user will struggle, the user will survive in giving the answers or giving the responses, because it would be really difficult. The user wouldn't know like how to add their answers, or the user will might become frustrated. So your user interface should be simple as possible. So for where you can just enter your prompts, you can just enter your commands, and that's it. After that, the next part is the knowledge base. So knowledge base is basically a database of related information about a particular subject. It's like the place where you contain all of your data at one place. It allows the storage, it allows the retrieval of information from that place. So when an expert system is developed, it's like several experts will be interviewed and they are asked to contribute their knowledge. They are asked several questions. You can ask them questions, maybe with an example of a questionnaire or maybe some surveys, and then this knowledge is then used to build a database that is going to be stored for your expert system. When an expert system is developed, several experts will be interviewed and they were asked to contribute their knowledge of a given field. Then the knowledge is then used to build a database that is the knowledge base for the expert system. So the developer will like want to like two types of knowledge from the expert, that is like a factual knowledge or a heuristic knowledge. So factual knowledge is most like that is mostly based upon the facts, or that is widely shared among the experts, but heuristic knowledge is the one that is acquired through some personal opinion, personal experience. So that is built upon the reasoning. So the part of the knowledge base is the rule base. Rule base is like I'm creating rules. Like your knowledge base, first of all, it is the database of related information where you are adding all the particular information of one subject into one area and you can access the information. But how this knowledge base is being developed? The knowledge base is being developed where you take information and knowledges from different sources, from different websites, from different documentations, or even from the people as well. Like you can take the information based on interviews, based on you can say surveys, right? And then the information is of two types. The knowledge is of two types. The first type is the factual knowledge, that is definitive and that is widely shared among experts. And the second part is the heuristic knowledge. That means that it's like required acquired through some personal experience or these reasoning. So based on these two types of knowledges, the database of the knowledge base is created, and then based on that database the rule base is created. You need to understand here the rule base. The rule base is like I gave you the first example in the starting of the class. If Mr. A likes red color, that means he is more interested into cars. If Mr. B likes blue color, that means he's more interested into bikes. What is this? This is a rule base. If he likes red color, that means he's more into cars. If he likes blue colors, that means he's more into bikes. So you see rules, right? Like what is the rule of Mr. Vamik's class? The rule is that when the clock is at like 9 o'clock or 10 o'clock, I start the class for A level IT. This is a rule, right? So the rule basis is basically a set of rules that will be used to produce an output or decision by the expert system. So these rules are used by your inference engine. Inference engine, we are going to discuss that as a base of reasoning. Reasoning means like to reason something, to obtain a solution to a problem. And then each rule will contain different parts like if, then. So a rule can have multiple if parts as well if they are being joined together. So if I summarize this up, a knowledge base is basically a component of an expert system that stores the knowledge provided by experts, and rule base is basically a part of the knowledge base that contains all the rules to be analysis by the expert system. This. See, this is an example. If A is greater than B and A is greater than C, then highest is equals to A. So the knowledge base should be a dynamic resource. Therefore, the expert system needs to have knowledge base editor. The knowledge base editor allows the knowledge base to be edited and updated when necessary. So a knowledge base editor is basically a component of an expert system that is used to amend or update the knowledge base. So what could happen if the expert system did not have a knowledge base? You can reply to this question. Like if it does not have a knowledge base editor, you cannot edit the information and you cannot update the information, because one thing you need to understand here is that the information keeps on updating again and again. Like the year passed, as per the opinions, as per the experiences of the people, the information is updated. So if you just don't update it, it will get obsolete. Now the next part is the inference engine. So inference engine is basically the part of the expert system that makes the judgment, that makes the reasoning, and that uses the knowledge base and user responses. It's like when you want to make the judgments, when you want to reason the knowledge means why, why is that, what's the reason. So it is designed to produce the reasons based on these rules and the knowledge base. So it is going to like ask the user questions, and based on their answers they are going to follow a line of logic that can lead to further questions and eventually to a final result as well. So the reasoning part is done by the inference engine. You should remember this by the word engine. It's like a car runs with the engine. Similarly, this inference engine, this will be responsible for narrowing down and finding the best of the solution. So the inference engine is mostly a problem solving tool. What it does is that it organizes and control the steps to provide the desired output. So there are two methods an inference engine can do and to stimulate, and that is also a part of the syllabus as well. Like in inference engine, there are two concepts that includes backward chaining and forward chaining. So let's get into it. So first of all, backward chaining. Backward chaining is based on a goal-driven reasoning. It's like dependent on finding a desired goal. You have to find a desired goal. This type of chaining is used when the possible outcomes are limited and they are definitive in nature. In backward chaining, the system tries to take a goal and repeatedly split it into sub-goals that are simpler to achieve. So the nature of the type of the system is that it moves backward from the goal to be achieved using the sub goal. So for example, what is your goal right now? Your goal is like to get a good grade in A levels IT, information technology, right? If you are going to break it down into some steps, what are the steps going to be? Taking classes regularly, doing the past papers, doing the quick revision and all of that. And these steps are eventually going to lead you to a good grade, right? Now, when you have broken it down, there should be two outcomes for this. One way is going to be the from the backward part, and one way is going to be from the forward part. So if you are going to go from the backward part, which means that your goal is to get an A, and you are going like first of all taking classes, doing the past papers, doing the revisions, and it's like you are moving from backward to your goal and you want to achieve that. So this is going to be known as your backward chaining. Backward chaining is like goal driven reasoning. It's like the nature of the system that it moves backward from the goal to be achieved. So this is the diagrammatical example of that. Like these are the sub goals and these are the rules as well. So what is forward chaining? Forward chaining is based on the data-driven reasoning. It's similar, but the only difference is that this type of system is used when a problem is more open-ended and the outcomes are not necessarily definitive. So the system is going to take data input by the user and move forward from rule to rule to suggest a possible outcome. So in backward chaining, you do not have the much feature, you do not have the much potentiality. But in forward chaining, it's more like you are more open-ended. You want to solve a problem, and the system is going to take data input by the user and move forward from rule to rule to suggest a possible outcome. So it will take the data input by a user, then move from rule to rule to find one where the clause for the data input is true. So it will then ask the user. So if I just summarize up, these are the important definitions. You can go through them. Backward chaining is this. Forward chaining is this, goal driven and data driven. These are the diagrams for the forward chaining. And the last is an explanation system. So explanation system is the part that is based upon the conclusions or the decisions that the expert system would provide. So this may not always be an obvious choice to a user, because the user may want to gain an understanding of how the conclusion or decision was determined. But in order to allow this facility, some expert systems have an explanation system built into them. So this provides you the reasoning, the process, that how it is achieved. So an explanation system, it's a component of an expert system that provides an explanation of how an outcome was achieved. What is the going to be the method of input? The output method is the method that the user will use to view any result produced by the expert system. So the method of output can be often in the screen of a display, or that will allow them to see the results on the screen, or any possible output such as a printer that allow it to be viewed or printed. So this is it for 7.1. I have discussed with you some concepts: user interface, knowledge base, inference engine, knowledge base editor, explanation system, method of output, forward chaining, backward chaining. Then I will start this 7.2 in the next class. So take care. Thank you.